Facebook again. Hey, yay. It looks like we're up.
Yep. We're good on Facebook.
Okay. Yeah, we're not on my end, but that doesn't matter. Always the same. Anyway, okay, we're up. Do 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 do. Thanks, everybody. Good night.
That'd be your cue to walk
Hey.
on in.
Good evening, everybody. Hey.
Oh, darling.
And welcome back to our Sunday night offering of Astronomy Outreach, the Sunday Night Astronomy Show. Hey.
Hey.
Hey. Hey, come on. Hey.
Hey.
Hey. Okay, here we go. That's better. Hey, good evening. My name is Chris Kerwin of Astronomy by the Bay. And first of all, I'd like to welcome back our two regular co-hosts, Mr. Paul Owen from the Moonshadow Observatory in Hampton, New Brunswick. Hey, Paul. Evening.
Oh.
And Mr. Mike Powell from the PFO Observatory here in St. John. Hey, Mike.
Hello.
Good evening. And good evening, everybody out there in Facebook and YouTube land.
On that land.
All that land out there. All right. Okay. On tonight's program, powering your equipment. What does it take? Computerized telescopes, dew heaters, laptops, cameras, they all require power. But how do you calculate how much power you need? And which power source should you choose? What ideas are there out there for making your own power source? And what devices require the most power? That's what we'll be talking about tonight. So we'll be looking at powering your gear to make sure that it's not an issue for your evening of observing, which can cut your evening really short, really fast, and make you really frustrated. Been there, done that. And that's going to be our main topic tonight. Also, if you're a golfer, you might want to pay attention to Binal Bud's target this week is the golf putter. The golf putter. Never heard of it.
Yeah.
The other putter.
The other putter. My other putter over there. Yeah. Also, tonight's show, Paul's going to be joining us as he presents another interesting Rosanna's Fun Fact segment. And, of course, we're going to have all, yay! And we're going to have all your wonderful photos to share as well. So sit back, grab your favorite beverage. You're probably sitting back. There you go.
You know what we should have done? We should have opened this up with Scotty and the dilithium crystal.
We should. We can start over again. Let's say goodnight, and then we'll come
All
back.
right.
Yeah. Just fun for that.
Give me a few minutes. I think I got him somewhere.
You probably do. There's no doubt you got a set of dilithium crystals. Okay, so sit back and grab your favorite beverage or snack and enjoy. And remember, this is a family-friendly live broadcast. So if you have any questions about tonight's sky, we're more than happy to try to answer them here for you. So let's get started with tonight's program.
Why would anybody want the second cup? I go right for the first cup.
I would too. Well, I finished the first one, and I'm on my way to my second one right now. So yeah. Anyway, okay. Let's get started. Where do you want to start? Let's start with power sources. Mike?
Sources? I thought we would talk about things that drew power. But, okay.
Okay, well, let's talk about that first. Paul?
Well, we can talk about anything.
Do we want to have a show? Or?
It looks like we can't get started. We need some power.
We need some power.
Okay, so we need some power. So obviously we need to talk power sources first.
Yes, let's go there.
First thing you're going to need is some kind of a battery pack. Now, a lot of these scopes, like say the Celestron 6 and 8 SE, they have a little hatch where you can shove in, eight or so, maybe even 12 double A's. That is not going to get you through a night of observing. It may get you to about 4 or 5 objects, but if you have dew heaters and things that are turned on as well and plugged into your mount, it ain't going to last you 15 minutes, those little double A's. You need something with a little bit of substantial bite to it. Car battery would be preferable, but they're so big and so heavy that you don't want to carry an extra spare car battery around. And, they're not cheap, but they do last for a long time if you do, build yourself a battery pack out of a car battery. After many, many years of, doing astronomy and playing with go-to scopes and trying to run all my equipment and stuff, I resounded to the fact that it was probably easier to build my own custom power pack. So I have built many over, the past few years now. And I'll just show you quickly. It's not a difficult thing to do. I'll throw it up here on the counter and drop this down a bit. You can see here, I started with basically, it's a plano tackle box is all it is. And it has a little hatch here in the back that I can lift up and put accessories in. Just not much in there, but I got a Barlow and I think an extra plug for plugging in my scope stuck in there. So I have a spare one if I go out for a night of viewing. You open up one side, and the thing I like about this one, if I move my mouse so I don't shut the computer off by accident, is it had a tray. And that little tray inside, again, holds my accessories. This is a charger that I bought off eBay for just plugging it in and charging it. I have another power cord for powering my scope and a couple of spare USB cables for my camera, but they sit right in that tray. And all I had to do was cut a notch right here out of the corner so the wire slips past it. And it sits right down in. You can close the top and it's got all your goodies in there. And since all my ends are capped, I'm not afraid or worried about a piece of metal in here shorting out anything. So now I build mine without a fuse in the power box itself because everything that I plug in has a fusible link. When you look at the plugins for your scope, this is a fusible link anyway. So if I got one here, why do I have one in the double it up by putting another one in the power box? So when I build mine, I don't put a fusible or put any fuses in the battery box itself. In this particular case, I got lucky. This is an 18 amp hour lead acid battery. And they use them in emergency lighting systems is the first place that I came across 12 volt batteries. And when the power goes out and you're in a building, they have emergency lighting over, say, the exits and stairs and stuff like that. And that's the type of battery they have inside them. Now, this one here is a little bit beefier. Most of them are 7 amp hour. This is an 18 amp hour, so it's almost double what the normal ones would be. And there was a kind friend that's sitting center screen in from my perspective that got it for me. And all I did was basically run 2 wires off it, one from the positive, one from the negative, and they come out through and come up into a switch. So I wired in the top a switch that tells me power's on or power's off, a light to tell me if I have power, and then this little plug is my charger plug, and that's what I plug this little charger I got inside. I just plug into that, plug it into the wall, and sit and let it charge, trickle charge. When you're wiring it up, just make sure positive goes to positive, negative goes to negative. When it comes to the switch, negative is bypassing the switch, and positive is basically cut and put across the switch. So when you flip the switch over, it connects the positive line as one wire, and you got your power. For the LED light, I just, or for the charger, I just bypassed it. So the charger is wired directly to the batteries. It doesn't have to go through the switch or the light or anything like that. And then that comes up to 2 cigarette lighter plugs is what I call them from Canadian Tire. These ones here are actually water sealed because you buy them for your boat. And stuck those in there. That's what it's wired to. And there's my 18 amp hour battery pack. And I think I charged this thing twice a summer and it gets me through. So there's a basic, very simple battery pack. They're really easy to build. What's that place? Clear Power Solutions. If you're looking for that type of battery, they sell them. Princess Auto sells those type of batteries in the surplus area. So they're available and easy to get. It's not something you have to really search for or buy online. You can get them, around here in the city or locally. And you get yourself a battery pack that's, nice and light. It's not a car battery. It does all the job and it keeps you running for the night. So there's a quick battery source.
Awesome. So Princess Auto too has these smaller packs, like smaller battery packs, and you can put a 7 amp hour battery in them. And I've been
ammo cases, yeah.
Ammo case, yeah, right. So I think they had a pack of 4 of them for $20, I think, this week.
They did. $29 for 4 of them.
Yeah, pretty cheap.
7 amp hour fits it in perfect.
Right. And the 7 amp hours, you can buy them at electrical wholesalers too. I've changed emergency lights at work, and that's where you can get a lot of them there too. So 7 amp hours really just all you really need for an evening for sure, I would think.
For sure.
Yeah,
They probably get you through a weekend depending on what kind of a draw you got.
Right. Okay, thanks, Mike. So there you go, folks. That's the way to build them. And if anybody wants one built, just leave your name here, and Mike will build one for you.
Sure.
In his free time. No, I'm sure that we can come up with a drawing. If you're worried about how to wire it up, just let us know. We can give you a simple drawing as to how to make all that.
I'll get a circuit diagram. Yeah.
There. Okay. Perfect. Okay, Mr. Paul, do you want to take it next?
Sure.
And I'll follow up at the end.
All right. I'm gonna maybe where did I put them? Oh, there it is. Okay, I'm just going to share my screen for what I'm going to show you because it's just some sources of stuff. Basically, what I'm going to talk about is just what you need to power your rigging for taking pictures for the night. Some away from home type of power and some around the home type of power. So let's get into it. So I'll just click on this.
While Paul's doing that, I'm going to wait till he gets on the screen, but I'm going to go down and grab my little battery pack, and I can show that after. So
okay.
Wait till you get up there, Paul.
Oh, I hit the wrong button.
Okay.
Paul's hitting the wrong buttons. There we go. Entire screen. There he is. And that's the one I want to show, share. And I will open this to this, possibly. And of course, everything's going to show on this screen. Murphy's Law, isn't it?
There it is. Okay, right back.
Okay, so there's a couple things that you can do for powering up your Astro equipment, and this is not one of the ones. Now, I don't know if this is going to let me, I don't see any arrows where I can click pictures back and forth. So this may be a bit of a pain in the foot. Let's ignore that for a minute. Let me just click that picture off. That shouldn't be like that. That should just come up like this. There it is. No, it doesn't let me move pictures back and forth. Well, isn't that wonderful? All right, I'm going to have to stop sharing for a minute, and I'm going to go with a different approach here. Hopefully I don't shut myself off, which I usually do. There we go. And am I still sharing, Mike, or am I not sharing?
You're not sharing at the moment.
Okay, maybe that's what happened. Let's try a window, see if that happens for us. And share. Okay, now we'll see if this will open up where it should. No, it doesn't. Darn. Okay, well, we'll have to try a different thing.
What's up?
Oh, I'm just having issues.
Whatever, right mouse click and open in Microsoft Photos or. Yeah,
everything's coming from sources other than what I wanted them to, and they're going to different parts of the page. So I'm going to have to.
Can you share a different screen?
Yeah, I'm going to have to stop sharing and go to a different screen. Okay. I didn't want to do that, but I will. Entire screen. So it'll be this one, and we're going to get that. Everybody falling into the vortex. Until I open this up, maybe. No, it has. Good God.
Oh, the tunnel of death. I love it.
Nothing's working today, I tell you. Nothing. There we go. Okay, so where do I want to start? I guess back here, right there. Okay, so for powering up imaging stuff, a lot of people use DSLRs out in the imaging world when they're going remote because the power requirements of a DSLR are extremely low compared to an Astro camera, where you would have to bring a computer to be able to run it. So by using a DSLR camera, first of all, the battery supply in cameras, they have a battery supply basically that come with them. So what you would certainly do is buy some extra batteries to be able to keep yourself running all night. So depending on the kind of draw you've got on your camera, 2 batteries should get you through most imaging sessions. So this battery, these batteries that you can buy third party, you can usually get them for somewhere around $20 to $30 a piece, and they last a long time. You can recharge and recharge and recharge them, and they go quite a long time. They got like a 1200 milliamp drawdown, so they'll they'll last quite a long time. If you find that you don't want to switch up your batteries in the run of the middle of the night, then you can go ahead and buy yourself what they call a battery grip. Now, what a battery grip is, basically, is you take the battery out of your camera, you take the battery door off of your camera, and then this device you see right here pushes up into where the battery would go into your camera, and then this little screws into the bottom of the camera, and that locks it into place. This then becomes the terminal of where the power is distributed from the batteries to the camera, and this little drawer underneath will allow you to open it up and house 2 batteries in there. So if you pop a battery grip in there, pop 2 batteries in, then you're not going to have to change batteries through the run of the night. And battery grips you can buy anywhere from 30 to to a couple of $100, depending if you're going with third party or actual proprietary grips. Canon are way overpriced. Anything that's a proprietary product from the main manufacturers are overpriced. So you can buy most of those things third party, and they tend to work very, very well, especially in this manner. The second thing that you can do, of course, is you can get these little DC plugs that will plug into, say, a larger battery and convert it down to the voltage that you need, because most DSLRs are anywhere between, say, 5.6 and 8 volts is what they run off of. So you can buy the correlating one that you need that'll convert it for you, and you can run that directly into your camera. Also, you can get these devices. And of course, now it's going to show over that screen. Wouldn't you know it? I'll just put it here. And how do I make that big? There it goes. So you can get this kind of a device. And what this is an AC power converter. So you take your battery out. This would slide in where your battery goes. And then this would just simply plug into an AC converter. And I do believe on this photograph, actually, can I switch? Yeah, no, I can, of course. On this one here. So when you buy the whole kit, what you're getting is the converter itself, which will convert the battery from the camera into a cable. That cable would plug into the source, and the source would plug into the wall. So if you're doing this in your backyard, you can just simply run an extension cord out, plug the extension cord, this into the extension cord, plug this into your camera, and you've got battery power all night long. And because you're not using the grip, I'll make that a little bigger so you can see it. And because you're not using the grip, there's less weight on your camera, because the battery grips add a little bit more weight to the payload, which means that you have to do a little bit more balancing when you're setting up your camera. So there's that type of device, and those devices are available for all brands, so you can buy them pretty much anywhere. These whole kits usually run anywhere from, say, $50 to $150, depending if you're going third party or proprietary. Let me see what else we got here. This is kind of a cool thing that you can use, and this is one of the newer lithium power tanks from Celestron. And these, the claim to fame for these and the lithium batteries is the fact that you can recharge these things over 2,000 times. So as far as buying a power supply, it'll probably do you the life of your scope, really, unless you're like 20 years old and you're going to live to be 70, 80 years old and still do this. Then you might replace them. But in any event, for a lot of us, it'll certainly power up for a long, long time. It's good, clean power. It refreshes quite quickly, and it does not develop a memory. So, if you're halfway down and you're going somewhere else you're going to be away from stuff for a day or two, and you want a full charge, go ahead and charge it. Don't worry about it developing a memory, because it will not do that. And this is from Celestron, and I believe these are somewhere in the neighborhood around $200 in Canada for one like this. So they're kind of nice, and they kind of take the place of its big brother, this one, the actual power tank, which is one of the first runs of the Celestron Power World. Now this is very similar to what Mike actually built, except it's got a lot of doodads on it that you may or may not need. It's got a red light, So if you want to see where you're going and that kind of stuff, and also it has a huge light on it. So if you're done for the night, you want to see where you're going when you're getting out of there, and you don't want to be tripping on logs and stuff that you don't know are there. You can certainly see where you're going. It has 2 USB ports on it, so you can charge things like your cell phone and other devices like that. You've got 2 DC power bays on it, cigarette lighter adapters, which you can run out to other things. And then, of course, right there, that would be where you would charge the unit itself. That would plug into the wall, and then you go ahead and charge it up. These ones, let me just see if I get any notes on them. These ones, of course, I had the actual amp hours written on it, but I can't see it because of where I'm at on the screen. I think there were somewhere around 7 to 10 amp hours, somewhere thereabouts. So these will definitely run easily for a solid night of imaging with a DSLR kind of a camera that doesn't have a lot of drawdown. I think that was pretty much the DC stuff. So let me just get out of there, and then I'm going to show you some AC stuff to run your rig. And so we'll go to there, and we'll see if this will pop up. There we go. Okay, so again, this is just another fancy rig that you can get. This will charge your car. This will inflate your tires. So it's kind of a cool thing if you're out in the middle of the woods and any of those things happen to you. It's nice to have that. You can get them from Canadian Tire. They make the marine one. I can't remember the actual name they put on them. But usually on sale, you can get them for $150. This particular one here, anywhere from $150 to $400, depending on where you buy it and the kind of brand that you buy. But they have a good long amp hour drawdown on them. They're a good solid battery, and they work very, very well. When you go to AC, that was actually should have been on my other pack, but when you go to AC, there's a number of different things you can get. These are one of the things that I use. I don't use this particular one, but it's a device like this I use out in the observatory. And what it does is you plug it into the wall, and it converts the output of this to DC. So if you're running a whole bunch of different things like a camera, dew heaters, motor focuser, all that other stuff, basically that will plug into a specific unit, which I'll get into in a minute. And then that one unit would send one cable down to this main power supply. And this power supply, this particular one you're seeing here is a 5 amp supply. That probably wouldn't be quite enough what you need if you're running all the stuff that we run in the run of a night. So you might want to run into something along the lines of this. This one here will give you up to, let me see if it says on the front of it, 100 amps. Excuse me. So this will certainly get you where you want to go and then some. So you can load whatever you want to load up on your scope and run everything through here, and you'll have absolutely no issues whatsoever. So and again, I'm not pointing out this one specifically. I'm just using this as an example. But you can get power supplies that are good, clean, solid, consistent power supplies with all kinds of drawdown for your stuff. To convert from all your DC stuff into an AC output for anywhere from usually 150 to about 600. So anywhere in between, you can find these things. But they're good, solid power supply. And again, this is if you're running AC and you're doing your imaging from your home or an area that has good, clean power. Now, when I was telling you about putting them all together and running them off of one box, this is kind of what I mean. So you can run systems like this. And what this is really, this one here is called the Pegasus Astro Ultimate Power Box. Mike has the Advanced Power Box, and I believe he has the original Power Box. And what these things really are they do two different things. They supply power to all of your equipment that's on your scope, including your mount. And they also have data distribution so that you can run all of your USB operated devices like your cameras, your motor focusers, and again, even your mount. So on this one here, on this side that you're seeing, this would be the power distribution side. It's got ports in it to run your dew heaters. So instead of running a separate dew heater and running a separate power to run that, excuse me, this actually supplies the power to the dew heaters, and you can plug your dew heaters directly into this. And instead of having to use the manual controls on the dew heater down here in this section here, this actually runs all of your dew, and you can set the temperature to draw to how much you want. You can have it for automatic so that it'll automatically run whatever is required. So if there are no dew issues, if the humidity level is low, it won't turn on at all. If there is, the opposite of that, a lot of dew going on, this will power up as much as it needs, and it will draw what it requires from here automatically. You don't have to set a thing. So that's kind of a nice device that way. And there's 4 12 output supplies, which is enough for most rigs. One for the mount, one for your camera, one for your guide scope. And then if you're running anything else, you've got a spare one for that. So there's the supply there. This one here is actually designed to run a motor focuser. So instead of you running your motor focuser into a power supply and powering up and yet another device, you plug your motor focuser into this. It will run the power for you, and it will also run the focuser for you. So you've got that all covered on that side. And of course, this is just the power to run it. On the opposite side is just the data pack, which is basically just a really nice, fancy USB port, where it's got all kinds of USB inputs on it, all running USB 3, so your data transfers are very, very quick. And this is all run by this interface on your computer, so you can keep an eye on what's going on your computer, which is really nice. And these are guaranteed not to short your products out. If you plug something in backwards, in the DC world, you plug something in positive to negative, you're going to blow stuff up. With this power box, that will not happen. And they've got safety stuff built right into it. So it's got a lot of cool stuff that's built in. So that's one of the things that you can use. The other one I want to show you quickly is this one. And this is the Asi Air Pro. It's the same kind of thing that I just showed you. Maybe not quite as elaborate and fancy, but it gives you the same sort of things where you can plug data into it, you can plug power into it, but also it's like a Raspberry Pi built in. There's a mini computer in there that you run on there, so you can actually do your astrophotography runs, collect all your subs on it. There's a little chip right here, which is your memory card. So once you've downloaded all your images for the night, you simply take that out and plug it into your computer in the house, and there's all your data stuff on it. So it's a really, really cool way to go about, instead of using a laptop out there, you can actually just use this. You still need a laptop for it to go to, but as far as the power distribution and all that, it basically centers everything. So all your cables from both your data and your power go to one central box, and only one line runs off this back to those power supplies like we talked about before, these ones right here. I think that, oh, sorry, and I wanted to tell you that that runs in Canada for about $360. Now it's on sale for $300. If you go to the Ultimate Power Box, like this one here, they run about $800, but they've also got the Advanced Power Box for around, I think it's $500, which would be that one. Oh no, that's showing that wrong picture, right church, wrong pew. But it's a smaller device. It does primarily the same thing with a few less things it can do. And then that one runs about $500. And then you can get the power box itself, which doesn't have as much stuff in it or control in it, but it will act as a distribution for power. And they run somewhere around $200, $250, somewhere thereabouts. So that is it for me. That is the AC power distribution and DC power supplies that are just basically a small sampling of what is available out there. So I'm just going to close all this out, and then I'm going to stop sharing. I'm going to try to. There we go.
Thanks, Paul.
That's it.
I've lost your guys' camera connections. I'm showing a slow internet connection for some reason tonight.
Oh.
Yeah, I can't see your faces at all, and I was getting messages that the internet connection was poor. Just a sec to see if it comes back up again. Just bear with me for a second. I don't want to make any changes, of course, because we're live on the show right now. But my broadcast software says everything's fine. Not sure where the issue is.
Looks like we lost the cameras on Facebook.
Yeah, we did. Lost your camera and Paul's both.
Paul's, yeah.
I still got myself up. That's the only one I got on the screen.
Well, you're up anyway.
Yeah, I guess. Yeah.
That's all that matters.
This is new. This is a new issue. So I haven't dropped any frames. Everything looks fine in OBS. Wow, not sure what's going on. That's it is when you're live, I guess. Okay, well, thanks, Paul. I guess we're gonna have to look at my ugly mug for a minute or two. We'll see if things change around here. Okay, I was going to talk a little bit about power dew heaters, I guess. So let me see if I can share my screen. And I'll go with this one. There's your picture back. And Paul was there and gone again. Wow, I don't know whether they continue or not.
Well, you might as well. If your
audio's still okay, they're saying. Yeah.
They can see you, then don't worry about it. Just keep going.
Okay. Let's see what happens here. Okay. I want to do it that way. Bear with me for a sec. Stop sharing again. And I wanted this one out. Oh, it feels like a little bit of a problem here. Hang on. Try this again. And see what that does. You guys able to see that?
I see dealing with dew.
There we go. Okay.
Yeah. I do.
Yeah, you do. Okay. You'll try to keep the connection going as long as I can, folks. I'm not sure what's going on here, but I'm on the line connection, so sometimes things do get slowed down on a Sunday night when everybody else is online. Anyway, dealing with dew and frost. There's a typical example for you. Hopefully that's not your scope at any particular time, but so what is dew, first of all, I guess, and why we are concerned about it? Well, dew does not fall from the sky. It condenses from the surrounding air onto any object that's colder than the air's dew point. The dew point, often mentioned in weather broadcasts, depends both on temperature and humidity. When the humidity is 100%, the dew point is the same as the air temperature. At lower humidity, the dew point is below the air temperature. So if the dew point is below freezing, you get frost instead of liquid water. Now, dew control. A familiar example of dew physics occurs when you take a bottle out of the refrigerator. If the bottle is cold, except for beer, well, I guess beer too, yeah. If the bottle is cold, colder than the air's dew point, then it drips with condensation. Your telescope is really the bottle. As you can see here, the dew that's collected on the front of the corrector plate of this telescope. A telescope in an open field is exposed to a whole celestial hemisphere of this cosmic chill. Correcting this issue involves shielding your optics with dew heaters and caps and other innovative ways to prevent your optics from dewing up. So the first line of defense against dew, therefore, is to shield your optics from as much exposure to the night sky as is feasible. Refractor telescopes, those ones that you look in from the end that's closest to you, they usually have a built-in dew shield that slides up over the top of the lens and extending beyond the refractor's lens. One of the nice things about an Newtonian reflector telescope is that its entire tube acts as a dew cap. So it's one solid column of air shielding the primary mirror at the bottom from dew. And for everything else, you can purchase a dew shield, and they come in both plastic and metal, and with or without their own built-in dew heater. So now my stream has just gone back to excellent again, so good, I guess. We'll see if your pictures come up here shortly. I keep getting messages on the stream, so Dew control. So dew shields are a great first defense. They do promote a stagnant column of air over the optical tube, which delays dew collecting on your optical surfaces. But the only way to really be sure that dew will not be an issue on a humid night is to consider some other means of dew control, as suggested here. This method consists of a power source, which is in this case over here, this lithium-ion battery, a dew heater controller, which would be this device, and specifically designed dew heaters of different types. Also, there are several types of dew heater controllers and several styles of heaters, but they all generally work on the same principles. Some controllers have a couple of what we call channels or outputs. Others have several channels with an ambient sensor even to control the outputs. The heaters come in many different lengths, of course. Now, we're all familiar with turning on an element on the stove or your baseboard heater or even your toaster. They all kind of operate on the same principle. It's either on or it's off. But to keep something warm and to cut back on the amount of energy required, dew controllers use something called pulse width modulation, or PWM. Now, it does kind of work the same way on a burner on a stove. This means that you can change the effectiveness of the heating band by adjusting the length of time that the heater receives power. This is done through the controller. So in the top case here, 0% duty cycle, so the heater is not on at all here. If I want it on to be on at 25% rated amperage, then you could see here that it's only on 25% of the time. It's off for 75, and then back on for 25, off for 75, like that. That's your cycle. Then the 50% duty cycle would mean that it's on for half the time and off for half, and then 75% on for 3/4 of the time, off for 25, and then full on. This method also does, of course, allows you to cycle the power more often, and it reduces your energy requirements. So calculating the requirements that you need for a battery pack, or for dew heaters, and again, along with that, your battery pack, we use Ohm's law, basically. Going back to some high school electrical work here, though, I guess, but your voltage is equal to your current times your resistance, and it can also be used the other way around. Your current can be your voltage over your resistance, and your resistance can be your voltage over your current. There's the three different formulas lined up. So I'll get into what this means here in a second. If I take a look over here to the right-hand side, there's a few examples. So if we've got a 12-volt battery, and we have a 6-ohm resistor, then what is our current? Our current is going to be 2 amps. In this lower one here, if your 24-volt battery and your current is 6 amps, then your resistance is going to be 4. So that would be this formula. Your final one, if your ohms are 8 ohms and your power is 5 amps, then E equals I times R, which means that's going to be 8 times 4, which is 40 volts. What about watts? Okay, watts are something that we're more familiar with, I guess. A watt is a measure of power. 1 watt is the rate at which work is done when 1 amp of current flows through an electrical potential difference of 1 volt. So then in DC circuits, 1 volt times 1 amp is 1 watt. So if I had a 12-watt dew heater on a 12-volt DC circuit, it would draw 1 amp. And that brings us all to this. And this is the chart that Mike found, an Excel spreadsheet, which is kind of really convenient. So we can plug all of our numbers into this chart, and it'll tell us at the end what ampere-hour battery we're going to require. So amp-hour just means exactly what it is. How many hours at a particular number of amps can I be a useful battery usage before my battery gets too low? So here's what we're looking at. So let's take an example. Maximum safe power factor 0.25. System voltage is going to be 12 volts. Now we're using nichrome wire in this case. Some of the previous dew heaters had little resistors in parallel across 2 pieces of wire, and they don't recommend them anymore now because the wire can short out the resistor. So now they just use a wire itself that has a specific resistance through the wire, and it's called nichrome wire. So you can find different gauges of nichrome wire, and that'll provide you with a different resistance for whatever you want to end up with for wattage. If we go down through here, so our primary objective, for instance, here we have a 10-inch diameter mirror. The heater element is going to be 31 inches long. The power consumption is going to be 8 watts. It'll be an 18 ohm heater, and it's going to draw 0.7 amps. We continue down to the finder. The finder is only 3 inches diameter. It has a 9-inch heater element. All the way over, we see that it requires 0.3 amps. Guide scope the same way. Your Telrad the same way. And then we start adding up some of the requirements for our mount, our camera, a guide camera, and any miscellaneous equipment. And we come up with a total current load of 3.1 amps. That's how much power we're going to consume that evening when we run all of this equipment. Now we're also going to say that we're going to try to run it for 6 hours. So 6 hours times 0.3 should be 18 hours. But that's not true, because we're going to derate the battery, because the battery is only 100% when it's brand new off the shelf. Every time you charge it, it's going to drop a little bit more in cycles allowed. So we derate the battery down to 80%. So that means we have to take that number and times it by 1.2, which would give us 24 ampere hours battery. So that's what we require for a battery to satisfy those loads, those current draws on those devices on that particular telescope. So what I'm going to do is I'm going to send the link here on Facebook and YouTube both. It comes from Cloudy Night's page. Mike sent me the link, and you can actually go in that and plug in your own values. So I think I still have that open. I can find it now. I'll go ahead here. I'll finish up this first. I think I only had the one slide left there, so yeah. You got to know where that one is. Habitable zone, comedy zone. Okay, so we'll stop sharing. And I think I can stop sharing here. That should bring us back. Okay, I can't see you guys still. I'm still having trouble with the connection apparently. But what I can do is I can show a few of the things that I was talking about there. So you guys can see me, I guess, okay?
Yep.
Mike and Paul, okay. So here's the different types of heater controllers, first of all. So this is one that I have. This one is actually made by Kendrick. And maybe I can take off my background. I might have to do that to show them. Bear with me, I'll have to get rid of my background here. Change background to 0. There. A little better. Okay. So this is the Kendrick heater controller, and it's actually a 4-channel one. So I can plug in 4 separate dew heaters to that one device, and there's my temperature control. Now it only has the one temperature control, so whatever I plug into it, they're all going to get the same temperature setting. You can go from minimum, of course, right up to maximum, depending on how much dew you're receiving. And I'll usually start it out at maximum and then cut back if I have to, but there's this little red LED there at the front that'll light it up. So that's one example. The one that I use more often is this guy. This is called a Dew Buster controller, and that's this one. Now it has a little bit different setup. What it has is it has two 12-volt plugs on either side, one on either side here, that allows you to plug in a 12-volt device into this. If you had some device that you had 12 volts, so it's 2 parallel ports that are the same as this port. But above that, there are 4 medium power ports, 2 here and 2 here. And they would be, for instance, for a Telrad heater or an eyepiece heater, that type of thing. The 4 top ports are for your larger heaters, and they're actually temperature controlled. So there are 2 ports at the top that you plug in a temperature sensor, which is this one here. That plugs into the top of it. And on the end of that is a small wire like this. And that wire clips around your heater, and then it just hangs in the air like this, and it's measuring the air temperature. So what you can do is you can turn on your controller, and you can have it set for 5, 10, 15, or 20 degrees above the dew point temperature. So this measures the temperature, and that sets your controller slightly above that temperature. And that will start to pulse these heaters. These heaters will flash on and off a number of times per second. And it gets a little bit stingier because the other type, you just turn a dial and it's whatever it is. This one is actually measuring the outside air temperature. So it's checking the dew point and you can set your controller manually to be just above the dew point temperature. So that tends to save you a little bit more energy when you're looking at battery power, that style. What I'm talking about when I talk about dew heater, here's a sample one. This is one for my 8-inch Schmidt-Cassegrain telescope, so that's the band there. This one's actually made by Kendrick, and it has a piece of Velcro on the end of it. You just kind of attach it to your heater when you pull it around, and it has what we call an RCA jack input there. That's a larger one. You can also get smaller ones that will go around your eyepieces, for instance, like this. That'll slap around a 2-inch eyepiece. It can also fit around a camera lens. And another style that they have out now, Mike had showed me this one, is these USB type of heaters, which are really kind of neat. This is around, I think I paid $12 for this on eBay. Mike might be able to price that a little bit easier, but this one just fits basically right around my camera lens, or it'll fit around the small scope too. So even a 3-inch refractor telescope, that'll wrap right around it. And the advantage of these ones is that they're USB powered. So if I have a small battery bank like I have here, these little battery banks you can buy at Canadian Tire or whatever, they have a couple of USB ports in it. I just plug it into the port and I turn on a temperature control, which is right here. And that temperature control can be turned up and down, and there you go. There's your separate battery pack for your camera or for a small scope. And you can mount that to your mount, and there are no wires hanging on the ground, and you can just turn your dial up and down to set your heat level. Very simple, very neat little package. I think that's a equivalent of like a 3 amp hour battery pack. So that's the way around that. That's some of the options that you have out there. Now I want to show you that Excel spreadsheet if I can. I think I've got it right here. I have to share my screen again. And I'm going to bring it over to here. So this is the Excel spreadsheet we were looking at earlier, and all of these values here are all adjustable. They all have a table to suit them. For instance, if I went down here and I changed that 8 hours to say 4 hours, it would recalculate the ampere hours down here at the bottom at 16. So it does show you exactly what you would require for a battery pack. So when you're shopping for a particular battery, 12-volt battery, you want to look at the amp hours, amps per hour, or how many amp hours you're going to use it. So if you have a 10 amp load and you want to run it for 1 hour, then you're going to need a 10 amp hour battery. That's how it works. And you're not going to want to discharge your battery down too low either. I know my telescope, my largest one, the CPC there, if I run at 11.5 volts instead of 12, the telescope goes wonky. It just does whatever it feels like doing. So it doesn't really work very well. So that's an Excel spreadsheet I'm going to put up here on the page here in just a few minutes. And you can manipulate that as much as you like. And you can download it from the Cloudy Nights website. I'm still back, guys. You guys aren't. I'm sorry about this, but I still got you there, I think, do I? Speak up, gentlemen.
We're here.
Okay.
We is here.
Thought it was going to be a lonely show here. Okay.
You're in the living room and we're in the kitchen.
There. Okay. This one's the same. I don't like it. Yeah, another error popping up. I don't know what my connection is doing. Okay. Anyway, let's get by that.
Might as well go right to photographs.
Yeah, we can't.
Yeah.
Well, do you want to try, Mike? Why don't you try sharing your? It might
I
still
can try
allow you
sharing
to
my
share your
screen
vinyl
and
bud.
see.
Yeah.
I'll try. We'll give it a shot.
Okay. Let's see what I see. Yep, you got him. Just don't have
We
your
got a Bono
webcam.
Bud?
Yeah, I just don't have your webcam. That's all. So
Well, I will say cool.
there, and I'll share
All
the
right.
link while you're doing that.
Binocular target of the week this week by Bono Bud is promised the golf putter. So, the asterism, the golf putter and ball, is located in Andromeda. It contains a straight line of stars forming the club's shaft and two bright stars perpendicular to the shaft forming the club's head. The open cluster NGC 752 forms the ball that it's about to hit with the putter. So where do I find it in the sky? Well, everybody can look up and see the great square Pegasus. At around midnight, you want to take your body, orient yourself at 75 degrees east-northeast, and look up. Like I said, you find the great square Pegasus. And if you come down 2 stars and go up 2 stars, that takes you to the Andromeda Galaxy. But if you go over 2 stars and to a 3rd star and down just a little bit before you get there, about 2/3 of the way to the 3rd star, you'll come across what looks like a golf putter. Here it is. You come off these last 2 stars and you can triangulate down a little bit and it'll bring you right to the golf putter. Well, what will you see? You'll see a line of stars that comes down like this, curves at the end, and that makes the bottom of the putter. And then this NGC 752 forms the ball that it's about to whack, actually. When you look at a pair of 7x50 binoculars or 10x50 binoculars, this is what it should look like. Again, the straight line of stars all the way down, the little hook at the end where the bottom of the putter is, and NGC 752, which forms the ball that it's going to whack into a hole. Comparing that to the full moon, like we always do, it's probably 3 times the size of the full moon when you stack it end on end. So it's a good sized target, real easy to see in a pair of binoculars, real easy to find, stands out against the background stars really well. And so grab your binoculars, run outside, take a look up, and see if you can find the golf putter. Space Force. Crap, I gave you our invade now.
Where is this? Up there.
Awesome.
And that's our butt target of the week.
Thanks, Mike.
Oh, that's fantastic.
All right. Still by myself out here, but anyway, these guys are still here, so. Thanks, Mike. Appreciate that. Let's go with, can we do a Rosanna talk? Or Paul? Yeah, me
You're not
too.
gonna have time. You gotta get the pictures in. It's
Okay.
5-2.
Okay, let's get to that because the show is running a little bit late or a little bit odd here anyway. So, okay, let's get to some photos, and hopefully these will come up. I guess it's going to be a hard connection next week. I won't be going wireless. Okay, let's see what happens here. There, I get you back, Paul, for some reason.
Oh, well, hold it now.
There, now you're back too,
Stop
Mike.
presenting.
Supplies.
You must have had another screen open or something, or somebody's presenting. Is that me?
That's me. But you're both back again now for some reason. Well, that's good. That's a good way to end the show. Okay, let's go to open some photos up. How's that?
Yeah.
Bring it on.
All right, here we go. All right, we've got Stefan Picard sent these in. He says, "Hi, Chris. Thought this would be a great way to display the amazing capabilities of a DSLR camera. On August the 27th, I was seeking the OWL cluster, so I mounted my old trusty Canon T1i on top of my Celestron 6SE and got my star sense to point to the scope to NGC 457, which would mean my camera would be pointed in the right direction. First picture shows my original capture that had an exposure of 15 seconds, f4 at ISO 1600. The camera was outfitted with a 28 to 70 millimeter lens kit set at 70 millimeters in infinity focus. You'll notice the outline vignette, which will be my second picture cropped and blown out. So let's take a look at the second picture. He said it's amazing the amount of focus detail and colors it captured when only using what seems to be maybe 10% of the original shot. The stars are sharp and full-sized original capture. Amazing. So yeah,
He's upside down.
he is.
Yeah, you make him look real easy.
He did,
He's
yeah.
doing a cartwheel.
He is, yeah, right there.
Yeah, doing a
Oh,
cartwheel.
yeah, no, it's easy to see.
Yeah,
Nice star colors too. Very nice.
nice job.
Yes, sir. Nice capture.
Well done. Thank you for that. Kathy sent this one in. She says, "Hi Chris, more sunspots. 2859 and 2860 are gone now, and 2861 is almost gone, but we have 2863 and 2864. Plus, there are some as of yet unnumbered spots and some small ones developing. Fingers crossed for some clear skies." Yeah. So
That's what we need.
yeah. I mean, this
Nice.
this solar cycle is really showing its stuff. We've only started to come out of solar minimum, and already we're getting lots of spots. So that's a good sign. We should have a pretty busy.
That's a nice capture.
Really nice.
Nice and clear.
Nice busy solar cycle coming up.
Nice image.
And I got this one from
Mr. Powell.
Mr. Powell.
Oh, that's the ugly one.
Oh, yeah, I
Lovely
know.
about that.
Nothing ugly about that, but you wanted me to share this one, I think.
That's the one I ended up with. I tried to get it close to the Soho picture, orienting it properly and trying to pull out a little more detail on sunspots. There was so much haze in the sky today.
But
It's
still,
really hard to focus. So that's a Soho shot there, yeah.
Wow.
Yeah, so look at
Look at
the
the activity. Isn't that wonderful?
it's crazy.
It's
Like, this has all happened just
getting
within a few
crazy.
days. Yeah,
And those are about the size of the Earth.
exactly. Right. So
So spots.
109 Earths would line up across the face of the sun this way.
I think if you zoom right out, it shows the Earth and Jupiter at the bottom of that photograph in comparison.
There you go,
for
right
size.
there. Yeah. So there's Earth right there. Yeah. So yeah, they're
That's fantastic.
they're the size
Wow.
of the Earth. Imagine.
Crazy.
Oh, it's nice to see the ball come to life.
Yes,
Yeah.
it is. Absolutely. I hope it stays till about 2024. That'd be nice because we've got a nice solar eclipse passing over the province during that time. So
Yeah, well, the last partial one that we did, we actually had sunspots on it back in
Yes, we did.
2017.
yeah,
So it was pretty cool. So it would be nice to get some sunspots on the eclipse.
wouldn't it be
Oh,
nice?
yeah. Really
Good
cool.
chance. I mean, if it's getting this active this soon, that's a good chance, I guess. Got these ones from Shelley Armstrong. She sent these couple in. There's one of the moon.
Very
said
nice.
Taken with a Samsung S20. Shelley said that she learned how to take a good moon capture from a TikTok video. And she was going to share it on my page. So she did share the, if you go to my page, you'll see a link there from a TikTok video that Shelley had shared. And it just discussed how to capture the moon.
Excellent.
So it basically zoomed in and you clicked on the moon with your finger onto the cell phone snapshot, of course, and then it would darken it down and focus it. And so, yeah, very nice. Thanks for sharing those.
Yeah.
We got
Oh,
Jamie Why Not's
nice.
here. Jamie says, "Hi, Chris. I took a photo of Saturn Tuesday night, and the next two photos I took of Jupiter tonight at 8 p.m. with my iPhone. So let's take a look at those. So here's her snap of Jupiter right in there.
Yes, sir.
Yeah.
Yeah.
So that's pretty bright to pick it
That
up
is
in
pretty bright.
in that much light. And there she said she got another shot of it. The last one I got was a bit higher up, and I managed to catch it in between the tree branches.
Trees, yeah. Nice shot.
Nice shot. Yeah.
Yeah.
Well done, Jamie.
Beautiful.
Thanks for those. Stefan sent in this one. He said, "Hi, Chris. Was up at 4:30 a.m. to capture Orion's triumphant return to my backyard. I don't want to hear it."
Yay.
That's our reminder.
They look like snowflakes already.
They do, yeah. A little dramatic excitement, he says. Focus on my favorite parts of the belt and nebula, Canon T1i with a 70mm lens at infinity focus, 30 subs at 8 seconds, ISO 1600 at f4.5, stacked in deep sky stacker. And processed in
Yes, sir.
Photoshop and
Nebula.
final... Yeah. Processed in
Popping out.
Photoshop and final touches in Lightroom. Thanks, Stefan.
Yes, sir.
Get this one for Lisa. Lisa Fanning. Lisa says, more fun in the sun this week. I'm learning how to use the pressure tuner. That's, to study different
good.
aspects of the sun on my hydrogen alpha scope. There's always something to learn in this hobby. I love it. So yeah, the pressure tuner is a neat little trick. Some of the detail will pop out when you start adjusting that a little bit. She has a 50 millimeter lint, I think. Yeah, mine's a 35.
Yeah, 50
but,
Yep.
yeah, the detail coming out there in sunspots.
Beautiful.
Well done.
Yes, sir.
And Lisa,
Nothing like looking at the filaments.
Yeah.
Through an 8 alpha scope.
And there was a pile of them apparently the last couple of days. Prominence is like all kinds of them. So we're gonna be getting a nice solar storm, I think, here shortly. We're gonna get some nice northern lights, I think.
Keep her fingers crossed.
Yeah, that's it. And Lisa has a page, of course, called Lisa's Lookup. Look her up on Facebook. She has her own page, and it's full of all kinds of nice stuff, all astronomy related. Get this one from Matthew Duprey.
Whoa.
Yeah.
Wow.
So Matthew says, it's not astronomy related, but this was an intense thunderstorm that passed through the Miramichi the other week.
That is so cool. You know how many times I've sat out getting wet trying to get that shot and have not succeeded.
Yeah.
That's shocking.
That's
shocking.
Wah, wah.
That is awesome.
I love it.
Well done, Matthew.
Love those shots.
Yeah.
Awesome.
I'll take any
Out
photo
there
you
with
send in.
Out there with my aluminum umbrella stuck high in the air.
Okay, and we got this guy.
Here we go.
Hey.
Oh,
Where'd that come from?
what's that?
That's something
I
that
don't know.
my favorite constellation.
Yeah,
at
that's
the-
your favorite spot in the sky.
Isn't it
The
ever?
detail in that is unbelievable.
Yeah.
Yeah, let's blow
Wow,
it up a little
Paul.
bit.
Yeah,
Well, that's Mr. Owen, the wall in NGC 7000, the North American Nebula in the constellation of Cygnus. 5 hours integration time, processed in Pixing site.
Well done. That is awesome.
Yeah, it turned out pretty good. I've got the same skies that Stefan does. He measured his skies the other night.
Okay.
Right.
And he's around 21 plus from his backyard, and last night it was just amazing. This sits at about 80 degrees in the sky, so it's pretty well straight up, and that's the best possible place you can take an image. And last night the skies were cooperating. I couldn't believe it. So I let that run all night. I went to bed. I got up in the morning and it was all done.
Wow.
And,
Wow.
so it was very fortunate. But the wall is one of my favorite things. I shoot that every year.
That's a nice capture.
Oh, I just love that part of the North American Nebula.
There's so much in there.
Where is that, Paul? Do I know that part of the sky? I probably don't.
That's it.
Hey, Leo's coming up too, pretty soon.
It almost
Next-
looks
next
like the
spring.
wall is damming back the stars from the dark spot. You see all those stars and then the wall, and then this big dark spot,
Yeah.
and it's damming the stars back.
It looks three-dimensional, doesn't it?
Does it ever?
Yeah. And that's kind of how gases and stuff work up there.
Yeah.
If you can get it right, you can actually get that depth.
Yeah, perception. Yeah, that's
Yeah.
crazy.
Yeah, it's just so enjoyable to watch. You can't really see that with a telescope, but if you're doing like what Mike does, the live stacking, you can get a really good look at that.
I got a funny feeling that'll be the next step in astrophotography. Would be 3D.
I think you're right.
Yeah.
Yeah. They're dabbling in it now.
Oh yeah,
Yeah, they
Tim
are.
Doucette's done some of it, and it looked fantastic.
it's crazy, eh?
Yeah.
This one was sent in by Paul Crowder, our friend over in the UK there. He says, hi, Chris.
Capture.
Yeah. He says, hi, Chris. Poor conditions yet. Managed to do a quick capture of the sun. Look at the same sunspots.
Yeah.
I was going to say that's the same kind of thing that Mike got with because over the UK they're pretty wet over there too.
Yeah.
And he probably had the same kind of conditions you did, Mike.
Well, if you can pick them off, you're doing well today. That's for sure.
Yeah,
He did, for sure.
Yes, sir.
fantastic.
And this one here, I think, wraps us up. This is Matthew Duprey. He said this is about 20 minutes exposure time. He said that he got this one around this time last year. He used a Celestron 9 1/4 Edge HD using Hyperstar attachment. And Celestron AVX mount. It's 26 by 4, 45-second exposures.
Very nice.
Nice done. Yeah.
Yeah.
That's
That's the
coming
nice
around
thing
again.
about the hyperstar. You can get that stuff so fast, eh?
Yeah.
Oh yeah.
Yeah.
The light sponge.
Yeah.
Yeah, F2.
Incredible. Nice shot.
Beautiful, beautiful picture.
Nice detail.
Yeah.
And if you'd like to send your photos in, we love to get them right here. Love displaying them, as you can see. Send them into Sunday Night Astronomy Show at gmail.com. That's where you're going to find us. And, that's it for tonight. Or just send them into my Facebook page, too. I love to get them there as well. So we stop sharing. And we're back. Look, all three of us are back. Hey, cool.
Hey.
Let's sign off quick. Sorry, folks. I don't know what happened there tonight. I mean, maybe a lot of people are home tonight and we're sharing bandwidth. I'll have to talk to Alliant and get them to discount my bill. Anyway, at least we made it through the show. That's the main thing, I guess. We're going to hold off on the Rosanna, I guess, till next week, Paul.
Well, actually, next week, aren't you away?
Oh, yes, that's right. I should mention that, too. Yes, I am away next week, so we won't be having a show next week. So we'll catch you in 2 weeks for sure.
Yeah, so I'll hang on to Rosanna one. So apologize to Rosanna for not being able to get that on, but
Yes.
All of her stuff is very, very interesting, and this is timeless.
Oh.
So it'll be okay in 2 weeks.
Yes. Okay.
Her
Awesome.
stuff is awesome.
Okay, so in closing in tonight, thanks again for your continued support. We so much appreciate seeing everybody on here. It's great to see a nice big crowd on here on a Sunday night, especially on a long weekend. A special thanks again to Rosanna, of course, for her contributions to the show. Again, we apologize for not getting it on there tonight, but we will bring it ahead in a couple of weeks' time. Also like to thank all those out there who share our program with others, including Trudy, of course, and NB Storm and Weather Center shares it as well. There's been a few other people that do share, so anytime you get a chance to share, just click the share button. We really do appreciate it. Gets it out to a lot more people than we can reach. So remember too, we do love getting your photos, so send them into Sunday Night Astronomy Show at gmail.com, and or just send them into my Facebook page, and we'd be happy to include them on our next broadcast. We're also looking for suggestions for topics for future shows, as we always are. So if you have anything that you'd like us to discuss on a future episode, please let us know. And the same address. And also, if you joined us from YouTube tonight, and there are a number of people I see there on YouTube tonight, please consider giving us a like and subscribing to our channel. And remember to tell your family and friends that we are here every Sunday night to entertain, and at least we stayed live. It felt like the old days. Like, oh, here we go again. This has been it's like a Groundhog Day show, you know, just keeps happening.
Yeah,
over.
exactly. He's getting hit by the same truck.
That's it. Yeah. So please let your family and friends know that we are here every Sunday night, except for next week. We're taking next week off. But I'll probably be live on Facebook anyway, doing something. To entertain you and educate you on the night sky. So for now then, from Mike and Paul and I, stay safe, everybody. We wish you all clear skies, and we hope to see you again in 2 weeks' time. As we'd like to say, guys, remember, keep your scopes pointed up.
Pointed up.
Thanks, everybody.
He loves the music. What can I say?
Yeah.
He does. And who does?
Bubblehead. Try to do the bubblehead.
Yeah.
Remember, those links are on that post that I put up, so you can grab that link and download that Excel spreadsheet for yourself. The post will remain up. You can go back and get it later. There. Whew. And we're ready. Good night, everybody.